Hi, everybody. Thanks for checking out this video. Today, we're going to talk about the Indiana lesson over exponents and roots. We are just working on the 7th grade standards right now. The 8th grade standards go much deeper into all of this. This is just kind of a very general overview of these topics. Okay, so first of all, a little bit of vocab. The big number, what you're multiplying. This one right here, that's called a base because it's what your answer is based on. Get it? I don't know if that's really the reason. That's how I always tell my students to remember it. The little number up here is your exponent. That little exponent tells you how many of the bases you're going to take times themselves. This whole expression is known as a power. So 5 to the power of 3, 5 to the third power, or you can also read that particular one as 5 cubed. You've probably heard with an exponent of 2, you could say squared, but the whole thing is called a power. So what this power is telling us is that 5 is the base, that's what you're multiplying. 3 is how many times? So 5 times 5 times 5. This expression would be equivalent to 125. It does not mean to take 5 times 3 and get 15. If I gave you, I don't know, how about 3 to the 4th? So 3 is called a base. 4 is called your exponent. The whole thing, the whole expression, 3 to the 4th, is called your power. Now, if I went to evaluate means solve it, do the math, get your answer. I would do 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the first thing we need to know how to do is to really show we understand what exponents represent is to rewrite each of these expressions using exponents. So on number 1, we're going to take the number that we're multiplying and write that 1 times our base. So that's a 2. We're multiplying 4 of them, so my exponent is 4. I didn't ask you to evaluate on these, just to write them as powers using exponents. So 2 to the 4th. Number 2, don't let the variable throw you. It's still the same thing. X is what we're multiplying. 3 is how many of them we have. X to the 3rd. Number 3, okay, this one's kind of in parts. On the 6's, I have 2 of them, so that's 6 squared. And then if you want to put a dot for your times, you can. You won't see me using the X for multiplication much anymore because at this level, you see X's for variables all the time. And you don't want your answers or your problems to look any more confusing than they need to, right? So you can put a little dot for times, or you can just put the A right beside it. There are 3 of those, so A to the 3rd. And then there's only one B. If you want to put B to the first, you can. Or you can just leave it B. I would take it either way. Number 4, that would be 3 to the 3rd and 7 to the 2nd. Number 5, now that -8, because it's in parentheses, that negative is so important that we keep it in parentheses. I'll be talking about that a little bit more here in a few minutes, but that is -8 in parentheses to the 2nd power. Okay, now it says evaluate. Evaluate is where you're actually going to do the math. So 4 squared, or 4 to the 2nd, means 4 times 4. That gives you 16. 2 to the 5th, 2 times 2 times 2 times 2 times 2. Let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Uh-oh, it hasn't done this for a while, but it's not writing. Okay, seriously. There we go. 6 to the 3rd, 6 times 6 times 6. I believe that's 216, but let's double check it. 6 times 6 is 36. If I do 36 times 6, that's 36. Yep, 216. When it's a 1, 1 to any power is still just going to be a 1. It doesn't matter if I have one of them, two of them, 9,579 of them. If all I'm doing is multiplying ones, all I'm ever going to get is a 1. Okay, now I said I was going to talk a little bit more about why those parentheses are so important. It's all about the order of operations. Let me say that again. It's all about the order of operations. When it's in parentheses, that -3 is going to travel, or the negative sign, is going to travel with the 3. So let's just multiply first. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. But now if I go back and I look at those negative signs, we talked a long time ago about how if they have a buddy to partner up with, then they're happy. Everybody's in a positive mood. It's a positive answer. So these two negatives make a positive. These two negatives make a positive. I get a positive 81. Okay. When it's not in parentheses, again, it's all about the order of operations. If you think of PEMDAS, exponents come right after your parentheses, right? Parentheses, exponents, then multiply, divide, then add or subtract. This negative in front of it, you could look at that as multiplying by a negative. Or I could have written, I have 0. This thing is really being difficult today. I have 0 minus this expression. At any rate, exponents happen before that negative sign happens. So the first thing I have to do is take 3 to the 4th. So 3 times 3 times 3 times 3. We already know that's 81. Then I deal with that negative. That negative out in front makes the whole thing negative. That's why they're different. It's all about the order of operations. Now on number 7, this one's really easy because you never have to think about it. Anytime you have a number to the power of 0, it always, always, always equals a 1. Anything to the 0 power equals 1. Let me show you why. So let's do 2's. Those are easy. If I have 2 to the 5th, I think we did that one earlier, you get 32. Let's make it 1 less 2. To the 4th is 16. 1 less 2. To the 3rd would be 8. So look, as I'm going backwards, I'm taking away an exponent. And look, I could divide by the base. I could divide by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. Let's do it again. 1 less exponent, divide by 2 is 4. 1 less exponent, I'm going to write it over here so you can see it. 1 less exponent, divide by 2 is 2. 1 less exponent, divide by 2. 2 divided by 2 is 1. So I know it's weird, but that's the rationale behind it. Anything to the 0 power equals 1. Okay, sometimes you'll see problems like this. Now, you should have in 6th grade, maybe even 5th grade, talked about prime factorization. That's where you make a factor tree. Like if I had, for example, 20, you write down any 2 factors of 20. So we could do 2 times 10, or we could do 4 times 5. 2 is prime. So I always tell my kids to circle it. Think of it, if you're sticking with the tree analogy, the tree has bloomed and now it's stopped blooming because you've reached your flower. 10, I could break down into 2 and 5. Those are both prime. So this would be 2 to the 2nd times 5. We're not really going to stress over that right now, because what I want you to know for the 7th grade standards, focusing on these exponents, I've seen this on our state tests before. If they want to know what number had that answer for a prime factorization, you need to undo it. You need to just multiply. So I'm going to do 2 times 2 times 2 times 2 times 5. We can multiply in any order because multiplication is commutative. I know I say that a lot in these videos. But look, I know 2 times 5 is 10. 2 times 2 times 2 is 8. 8 times 10, I get 80. 80 had a prime factorization of 2 to the 4th times 5. Let's try this one. So this one would really be 3 times 7 times 11. That's 9 times, I'm going to do 9 times, oh my gosh. Here I started to say 9 times 7 is 63, but then I decided at the last second I was going to do 9 times 77, and I decided to write a combination of those. So I'm going to do 9 times 77. We don't need a calculator for that. We can do it. 9 times 7 is 63. Carry the 6. 63 and 6 is 69. 693 has that prime factorization. Okay, so we've been talking about exponents. Let's do the inverse or the opposite of that now and talk about square roots. Square root versus square. A root sounds to me like a small thing, right? Think of a root on a tree. It's the small thing. It's what's helping it to grow into the bigger thing. In this case, the bigger thing is the square. So the square root of 1 is 1 because 1 times itself is 1. The square root is 2. If I take 2 times 2, I get 4. So if I go backwards, if I say the square root of 4, I get 2 because 2 times itself equals 4. The square of 3 is 9 because 3 times 3, this thing is really being a pain in the booty today. 3 times 3 is 9. If I had said what's the square root of 9, you would say 3 because 3 times itself equals that. So the square of 4 is 16. The square root of 16 is 4. The square of 5 is 25. The square root of 25 is 5, and so on. Okay? So the types of problems that you're going to see. If it just flat out says, find the square root of 10, it's asking you, what do you take times itself? I said 10. How about 100? Find the square root of 100. It's asking you what times itself equals 100. See, I got ahead of myself because the answer is, of course, 10, right? The square root of 49. What times itself equals 49? The answer would be 7. You can also ask that same question by using what's called the radical symbol. I always feel like I'm going to age myself here, but the old school Ninja Turtles, especially back in the 80s, they were always like, that's radical. I always feel like a Ninja Turtle when I say it. And again, I'm showing you what an impossibly huge dork I am in this video. It's fine. It's fine. Anyway, that radical sign, it's the square root sign. It looks like this. It's like a long division sign with a little check mark on it. That means find the square root of 196. So what times itself equals 196? Now, if you ever get one that you don't have memorized, or you get a really big one that you're not sure of, or you get what's called an irrational number where it's not a nice, neat whole number answer, you should have a calculator that will do this. You can always just Google it on your Chromebook or on your computer, whatever you're on. Just Google calculator, look to see if it has that sign. If not, Google calculator with square root. But sometimes you hit the square root button and then the 196. Some calculators you would do 196 and then hit the square root button. But anyway, for that one, you should get 14. 14 times itself equals 196. If there's a number on the outside, or a sign on the outside, you just keep that sign. It's like what I was saying with the parentheses, with the order of operations. You would do the square root first. It's like an exponent. The square root of 4 is 2. Then put the negative on the outside. This number 5 looks super funky, but it's really nothing different. The square root of 9 is 3. And then it's just saying put a plus minus outside. It means your answer is a positive 3 and a negative 3. This is a fast way of saying 3 and negative 3. Just a little shortcut for writing it. Now, number 6, when the square root is on the inside, it's a very different kind of beast. When the square root's on the inside, there is no answer. There is no answer when the square root is on the inside. The real term for that is undefined. It means no solution. The reason why square root means what do you take times itself to get that answer? You can't take something times itself and get a negative 16. Because if I take, I'm just going nuts here. If I do negative 4 times negative 4, I get a positive 16. If I do 4 times 4, I get a positive 16. I can't do one of each, or I'm not really taking something times itself. So when the negative sign is inside, you cannot do it. Sometimes you'll even see this symbol here. It means no solution. Square root of a fraction, again, looks super intimidating, but it's not. It really just means do the square root of the top and then do the square root of the bottom and then reduce your answer if possible. The square root of 121 is 11 because 11 times itself equals that. The square root of 144 is 12 because 12 times itself equals that. So it's just 11 twelfths. Number 8, the square root of 4 is 2. The square root of 9 is 3. It says put a plus minus on the outside. So that really means 2/3 and negative 2/3. Let's have a little bit more to show you. When you're solving an equation means finding any number that you can put in place of the variable to make that a true sentence. So this is saying, what do you take to the second power? What do you take times itself to get 25? Hopefully right away you thought, well, 5, because I can take 5 times itself to get 25. In my class, I would immediately say half credit for that answer. And I would drive them crazy for a while I let them struggle to figure out why I'm saying half credit. The reason why is because equations actually require 2 answers for things like this. Yes, I can take 5 times itself to get 25, but I can also take negative 5 times itself to get 25. You need both answers for that. You can write it that way, or you can say plus minus 5. So number 2 is asking for any number that you could take times itself to get 400. If I do the square root of 400, I get 20. But I can also plug in a negative 20 because if I do negative 20 to the second power, I also get 400. So I need both of those answers. Whoops, I bumped it. You need 20 and you need negative 20. And again, you can write them both out or you can say positive and negative 20. No different for the fraction ones. The square root of 81 over 100 would be 9 over 10. But I could also plug in negative 9/10 to that equation and get the same positive 81 over 100. So you can write them both out or you can say positive and negative 9/10. Last page. Word problems typically will only require the positive answer. Now, not every time, but a lot of times these will be problems that involve area of shapes, or then it'll ask you to go a step further and now take that and find the perimeter like this one does. But the area of a square is 49 centimeters. So this is saying you take something times itself and you get 49 because in a square, every side is the same, right? So if I call them all x, to find the area of that square, I take x times itself. Well, on the page I just showed you, we would have said for this 7 and negative 7. But you can't have a negative side length. How could you have a drawing where you measure something and get a negative measurement for it? That would not exist for a length of a shape. So that means each side of my square has to be 7. Then for the perimeter, if I add all those up, this says now find the perimeter. 7 plus 7 plus 7 plus 7 gives me 28, and perimeter would just be centimeters. So again, the reason why I only put the positive is because this one is dealing with a measurement. You're not going to have a negative side length. Okay, that's the end of this lesson. Thank you if you watched the whole video. Hopefully it helped you. I know my classes have an assignment that go along with this video. So if you really watched it, you should have been able to find every answer in there. Thanks so much. As always, come back anytime you need 7th grade math help. I've got a video for every lesson that I teach. Until next time, bye.